Alright, whenever you see a parabola, I can't unsee this now. We have a shark. I know, you're welcome. However, we also have a calculus problem, so let's get back to that. So it shows us the gradient function, f prime of x, of some function f of x. Cool. And the question is asking us to sketch this original function. Alright, so what the gradient function tells us is the gradient of the original function. For example, this point right here has a y value of 0. So that tells me the original function along this x equals minus 2, along this line, our original function will have a gradient of 0. So that's a turning point. So it could be a max or a min. We don't know where it goes yet, but we know the gradient is 0. Similarly, when x is 4, our original function will have a gradient of 0. So I'm just putting in these dashed lines to help us in a moment when we sketch our graph, so we know where to put our turning points through. So once more, the gradient function f prime of x tells us the gradient of our original function. So where we have an x-intercept, the y value, right, the gradient of the original function is 0, which means it's a turning point. And so since these are on the same scale, I just dropped the dashed lines down onto our original function plot. Alright. I'm getting a bit ahead of ourselves though, or myself, unless you're here with me, which I don't think you are. What type of graph are we dealing with? So right now we have a positive quadratic, right? A positive parabola, so that's like x squared. This is the gradient function. So when we take the antiderivative, right, when we integrate, we would expect a positive cubic, right, an x cubed. So we would expect this kind of shape. So positive quadratic becomes a positive cubic, which has two turning points, right? It starts with a maximum and then a minimum. So back to our plot. Since we have 2 points that have a gradient of 0, we know it's going to have a maximum and then a minimum. Something like that. Now, so we know it's a positive cubic, so it must be maximum then minimum, but how do we know where it's positioned? Right, there's all these possible cubics that do have the turning points, well, roughly in the correct place. My sketch is a bit, okay, they're all off, but you get the point. How do we know its exact position? So the question tells us the original function passes through 0, 3. So 0, 3. So the curve must go through that. What else do we know? We know that this must be a maximum and this must be a minimum. So with that, we can now sketch the graph. All right? It is a sketch, so it won't be perfect. So maximum, make sure we go through the right point, 0, 3. And then minimum. Something like that. Yeah. And that would do. Right, again, if you're a little bit off that, maybe you went steeper, that's still correct, right? Because you pass through the point, your max is at -2 and your min, well, is almost at +4. Yeah. And so for this question, if it's a positive cubic and it goes through this point, that is achieved. If it also goes through the max and the min at the right values, so at -2 and +4, that would be merit.